Now let us start with the second problem. Now I am taking G, which is the set of all numbers of the form a plus b root 2, where a and b are rational numbers. So you have to look at this set carefully. So if I take any number which is 2 plus 3 upon 4 multiplied by root 2. So all numbers are of this form, where a is a rational, b is also a rational number multiplied by root 2. From this, so I will collect all such numbers. From all these numbers, I will omit the number 0, because 0 is also of the form 0 plus 0 times root 2. So this number I will remove from my set G. So that set will become G minus singleton 0. This set G minus singleton 0, I have to prove that it is a group with respect to usual multiplication. Now let us start solving this exercise. So I will take two numbers from this set. So that is our closure. So let a plus b root 2 comma c plus d root 2 belong to my set G minus singleton 0. So both of them are numbers where a and b, c, d all cannot be 0. Okay. So then I will multiply them, because I am using the operation as multiplication. So a plus b root 2 multiplied by c plus d root 2 is equal to, when I simplify this, I will get ac plus 2 times bd plus ad plus bc multiplied by root 2. Both of them will have a factor root 2. So this is looking like something plus something root 2. A dash plus b dash root 2. This is a dash and this is b dash. Now what is a dash and b dash? A dash is ac plus 2bd. A, C, B and D all are rational numbers, because A, B, C, D all are rational numbers. So AC plus 2BD is also a rational number. Similarly, AD plus BC is also a rational number. So I will get this rational number plus something rational number multiplied by root 2. So this means that this multiplication is again in the set G minus singleton 0. Why minus singleton 0? Why this cannot be equal to 0? Because ABCDs were not equal to 0. So this product will completely not become equal to 0. So let us go for the associativity. Again, I will say that you can check associativity in your free time. So it is something like a dash plus a plus b root 2 multiplied by a dash plus b dash root 2 multiplied by a double dash plus b double dash root 2. And this will be the same answer when I multiply these two people first. So it is a plus b root 2 multiplied by a dash plus b dash root 2, and then multiplied by a double dash plus b double dash root 2. So these two, if I simplify the left hand side, if I simplify the right hand side, I will get the same answers. So next is the identity. Now it is clear that what should I multiply to a plus b root 2, so that I will again get a plus b root 2. So this person is the identity. So if you guess the identity here, you will clearly understand that E must be 1. But is 1 of this type? Yes, because 1 is nothing but 1 plus 0 times root 2. So 1 is also element of this set. So yes, so identity does belong to my set G minus 0. Next is inverse. So let me take some element of this G minus set 0. So let a plus b root 2 belong to G minus singleton 0. This means that a plus b root 2, first of all, is not a 0 number, because it is minus singleton 0. Now what should I multiply this number so that I will get the multiplication as identity. So a plus b root 2 should be multiplied by which person so that I will get it identity. And who is identity? Identity is 1. So obviously this person has to be, so if I call this person to be alpha, so this means that alpha has to be equal to 1 upon a plus b root 2. So we get the inverse here now, but we have to not only stop here, we have to show that this person actually is an element of the set G minus singleton 0. So this does not look like something plus something root 2. This number does not look like that. So I will rationalize it by a minus b root 2 upon a minus b root 2. And this simplification is a minus b root 2 upon this a plus b root 2 multiplied by a minus b root 2 will be a square minus 2b square, and that will become a upon, what is alpha equal to? Alpha is a upon a square minus 2b square plus minus of b upon a square minus 2b square multiplied by root 2. So do you see that this number is a rational number because a and b are rational numbers. So this expression is also rational number, and this expression is also a rational number multiplied by root 2. So therefore alpha belongs to G minus singleton 0. Now only one question you should have in your mind is that what will happen if this denominator becomes 0? So will the denominator become 0? So we have to ensure that. So for this, suppose it is 0, what will happen? Then this will mean that a square upon b square is 2, and this will mean that a upon b is root 2, and therefore a upon b will become an irrational number. But we know that a upon b are rational numbers. If I divide a rational number by a rational number, I will always get a rational number. So this is not possible. Correct? So a square minus 2b square is not possible. So this means my entire proof is now correct, and all these 4 properties have now been shown by us, and therefore we can surely say that G minus singleton 0 with respect to the multiplication operation forms a group. So this ends the solution of our exercise.